So here's a good record of your beautiful Algebra 1 career. You have now learned about three different styles of functions: the linear, the exponential, and the quadratic. So we're going to take a little time to make sure you can find out the difference between those two. The very first way to think about it is just look at the graph. You've got a linear graph, that's a line. An exponential path and a quadratic path are both nonlinear, but they have different curvatures to them. I'm sure you're a big fan of equations, so remember the linear is y equals mx plus b. This is the queen of all equations. You use this all the time. In the exponential world, the equation would be ab to the x, where a is always an initial value and the b is always like a growth factor or a decay factor. So an example of this might be you have 3 bacteria in a petri dish and they're doubling every hour. And I can go over here to the quadratic equation. A quadratic equation is going to be one of degree 2, meaning the strongest or largest exponent is 2. A good example of that is anytime something is projected through the air and gravity is going to influence its path. So you can identify these three different types based upon looking at the graph, and you can get very good clues from their equations. But we're also going to look at and see what you can determine from a data table or a t-chart to determine the type of graph. If we have a linear style function like y equals 3x minus 5, you can tell that that's linear because this is y equals mx plus b. But if you were given a data table and you didn't have this equation, you would look for the common difference from value to value. We went up by 3, up by 3, up by 3, up by 3, up by 3. We had a common difference going to the next term of always plus 3. When there's a common difference, you have a linear scenario. But now let's compare what we just saw there to an exponential scenario. So in a case like we're looking at here, we would have a y equals ab to the x style of equation. But if you didn't have that equation and you just had that data table, you might first look for a common difference. Here we went up by 1.5, then up by 6, then up by 24. That's definitely not a common difference because it keeps changing every time instead of being consistently plus 3. The next thing you might try is, hey, are we multiplying every time? And in this case, times 4, times 4, times 4, times 4, times 4. It keeps working. So what we have is what's called a common ratio of times 4. Anytime you have a common ratio, you have an exponential scenario. And the last one to identify from a table is the quadratic. And that one's going to be a little bit different, but let's first go through the process. You might first look for a common difference. Here we went plus 1, plus 3, plus 5, plus 7, plus 9, plus 11. That is definitely not a common difference. But I also don't see a common ratio, meaning I can't multiply by the same number over and over to get to the next y value. So common difference didn't work, common ratio didn't work, but we're going to do something tricky with our common difference. Going back, I did a plus 1, a plus 3, a plus 5, and all of that is shown right here. I recopied this t-chart and I show a plus 1, a plus 3, a plus 5, a plus 7. But now in a quadratic, if I take that column of common difference, which turned out not to be common, but at least I have a pattern here, and now I go one more step. In this attempt to look for a common difference, which failed, I ended up going plus 2, plus 2, plus 2, plus 2, plus 2. So this would be called a second difference or a second common difference. In the very first try, I didn't get a common difference, but I couldn't find a common ratio. So I looked to see if there was a pattern in my common difference, and there was. So this one's a little bit awkward, but if I get a scenario like that, I know I have a quadratic scenario. So if you're going to identify the type of function, your best option is look at a graph if you have a graph. Then if you don't have a graph but you have an equation, you can recognize the different forms. And if you don't have that, you have to analyze the table looking for a common difference for linear, a common ratio for exponential, and a common difference of the common difference for the quadratic. Ew.